Hello, good morning, and welcome to another installment of Music 110, Introduction to Audio Technology. I am your host, Dr. Clint, and today we are moving to the next unit of this course. Congratulations, everyone. You have graduated from Unit 1, which is really all of the theoretical foundation for this course. And we're now moving into actually using computers to make sound and make music. So congratulations, you've gotten this far, and I hope you're excited to enter the remainder of the course, which is really much more focused on being creative and making music. In order to do that, we're going to have to learn how to use some software. And the software that we're going to be focused on in this course is Studio One. You see a screenshot or a Studio One window in front of you on this slide. We'll be working with this software in here in order to be creating all of the music that we're going to be creating and learning all the techniques that we're going to be learning. As I've said a couple of times, I'm not requiring that you use Studio One in here. If you prefer to use another type of software, that is fine with me. The reason that I use Studio One is that there is a free version for to download, and that way everyone gets a free version. Studio One is a very powerful piece of software. Just because it's free doesn't mean that it is not good. And we'll be able to learn techniques and concepts that transfer over to all digital audio workstations with Studio One. But if you're working in another digital audio workstation, that is fine. I would like you to let me know if you are a person who is working, who has decided that you just want to do this in Logic, for example, or some other, or Ableton Live, some other digital audio workstation. That is totally fine. Just let me know, because that way I will know who isn't working in Studio One, and I can figure out ways to reference some things in these other DAWs as best I can. Okay, so here is the window of Studio One. It is an example of the digital audio workstation. Whether we're talking about Logic, Pro Tools, FL Studio, Ableton Live, etc., these are all examples of the digital audio workstation, or the DAW, which is an application for the recording and engineering of audio. Now, in front of you, you see this window, and you'll notice right away, oh my God, that is a lot of buttons. And it is a lot of buttons. And this isn't even all the buttons here. There are hidden buttons within pop-up windows. There are all sorts of There's so many different parameters that you have access to when you're dealing with a DAW, and it can be really overwhelming at first. So I want to try to introduce the DAW, the Digital Audio Workstation, in such a way that maybe it's a little bit less overwhelming, and we can start to think about all of these different buttons as fitting into different categories. So to start off, I want to just talk really briefly about the Analog Recording Studio. And the reason I want to do this is because when we open up Studio One, I want to be able to really refer to what's going on in the Analog Recording Studio, because then I think that this makes it a little bit easier to get your head around all of the different things that are happening within a digital audio workstation. So any DAW is really a digital representation of the control room of a recording studio. A recording studio, technically, a recording studio is the sound room in which the recording happens. So here we see a window over here to the left. It seems like that is where the recording is happening. This is where the musicians are tracking the music. There are microphones in there. There are, sound walls, all that sort of stuff. And all of the things that are being recorded in the sound room are going through cables and coming into this room, the control room. And this is where the recording engineer sits and does all the mixing. This is where the musicians come after they've tracked, and they listen back to what it sounds like, and they make decisions on whether they need to take a new track, et cetera, et cetera. So in this control room, there already you can see there's a whole bunch of different hardware devices. And really, we can think of all of these different hardware devices as essentially broken down into really three broad categories. So 1 would be tracking, 2 would be effects, and 3 would be playback. So obviously you see those speakers there, that there on top of the desk. Here is one speaker, here's another speaker. So this is what you're listening back to. This is how you're keeping track of what's going on in the recording studio. When you record in here, there's you sing into a mic, say, the cable from the microphone goes through the wall, and then it is plugged into this mixing console. This is a mixing board. If you've ever seen a mixing board, you can kind of picture in your head that the mixing board has different channels, different places that you can plug into. And each channel is independent, and then it mixes all of those channels together. So say you could plug in your voice, your guitar, and your friend's computer into 3 different channels. And then you have independent control of those channels. You can change the volume with little sliders. You can change the sound with equalization. We'll learn more about that later. But the thing is what happens is all of these things that you plug into the mixing board eventually get mixed down to the master track, which is a stereo. This mixes down all of the things that are happening in this room into a stereo output. Okay, so the mixing board takes many, many, many tracks, brings them together, and combines them into 2 tracks, left and right. Over to the right here, we see a whole bunch of other buttons, sort of like Star Trek wall of buttons and knobs and displays. These are effects. And so what these allow you to do in an analog recording studio, you would have a cable that would run from the mixing board to these effects and then back, so that you could put what you could decide, all right, I want to send my vocal that's on the first track into some reverb, then bring it back so that my vocal has some reverb on it, added to it. So these are all sorts of different effects that you can run whichever tracks you wanted to through them. The way that that's happening is you're sending the signal, the waveform, through a cable into the effect. The waveform is being changed by the effect and then sent back to the mixing board, and then that comes out of the left and right output of the mixing board. So we have 3 categories. We have the thing that is playing back, the master track, the stereo master track. That is what we hear. Then we have all of the stuff that's happening within the mixing board. Many channels that can be sent to any number of effects, brought back, and then back to the master mix. So this is what's happening in an analog recording studio. A DAW, a digital audio workstation, mimics that, does that digitally. So a DAW, like a like a analog recording studio, allows multi-track recording, editing, and mixdown. So you can plug in many different inputs and record them simultaneously, edit them independently, and then mix them all down to a stereo output. A DAW also allows for MIDI sequencing, editing, and scoring. This is something you would not be able to do in a fully analog studio. And what this means is, if you have a MIDI keyboard, you can record not just the audio that's coming out of the MIDI keyboard, but the MIDI itself. And we're going to learn all about that when we get to the MIDI unit, so don't worry about that. Point being, you can record the audio that's coming out of that computer, or you can record the MIDI data that's coming out of that computer. A digital audio workstation also allows you to easily synchronize with video. An analog studio does not do that. It allows all sorts of integration with other devices. It allows you to bring in other effects, digital effects, not just the hardware effects that are on the sort of Star Trek wall. And it allows you to integrate with other software. So, for instance, you could be recording using one digital audio workstation, one DAW. You could be recording in Pro Tools, but say that you have somebody in your band that does stuff with Ableton Live. You can do all sorts of things that synchronize with that between these different softwares. So this means that the DAW has a bunch of advantages that a analog recording studio does not have. It can integrate much more so than a fully analog recording studio can. So it can like the way that it integrates is because everything is digital. It allows to just integrate more tracks, direct communication between all these different types of hardware. It allows for more communication between different different languages, really. What we're going to learn is that MIDI is its own programming language. And what the digital audio workstation allows us to do is synchronize information that's in the MIDI language with information that is in the digital audio language, or how computers understand waveforms, and it is able to synchronize all of that. It makes things a lot faster. You don't have to, every time that you want to incorporate a new effect, you do not have to plug it in. You just press a button. You're able to save and recall performance data, not just when you're recording somebody in the sound room, but also you're able to record and recall editing information. So this is what we call automation, and we're going to spend a lot of time talking about it in here. But basically what that means is, if your friend is singing in the recording room and you are in the control room, and as your friend is singing, you are moving the fader up and down to change the volume. The DAW, the digital audio workstation, can record your moving of the fader up and down. It also means that we can expand indefinitely because of the integration and connectivity that a digital audio workstation allows. So these are all of the advantages that a digital audio workstation has over a purely analog studio. There are advantages to an analog studio, for sure. And there are a lot of people who really swear by recording fully analog, or say that it offers a very special sound. For us, we are going to be working with the digital audio workstation. I'm talking through all of these advantages to really emphasize why all those buttons are there. All of those buttons are there for integration, communication, speed, automation, and expandability. So here we are, back at all of those buttons. Already you can start to think about how The when we look at this screen, at this window, you can start to categorize in the same way that categorize all of this information into and being analogous with a recording studio. So the tracks themselves are like let's say the reel-to-reel tape onto which the waveforms have been recorded. So these are the tracks coming into the mixer. Each track has its own channel with its own fader. Right, here are the faders that I'm putting my mouse over. So I can change the volume on the lead vocal up here, or I can change the volume on the chorus, etc., etc. So each track is associated with its own input to a fader, to a channel. These would then be all sent to the main. This is the mix. This is where all of these tracks are coming to. This is what we hear when we hear the sound coming out of headphones to left and right, or speakers left and right. So all of these tracks gets mixed down into the master. Over here is where we would find our effects, and we'd be able to drag the effects onto individual tracks. So already we can see we have output or speakers, we have the inside of the mixer, we have the recording itself. This is maybe more like the sound studio, and we have the effects or the Star Trek wall. Now, you guys have been in a Dr. Clint class for long enough to know that I can't rush into the fun without giving us a little bit more theoretical terminology. I'm going to give you 2 new terms. These are important because as soon as we start working within the DAW, you will find that these 2 concepts are really important. The DAW is, like we said, a way to connect and communicate, and it is also a way to record and to listen back to that recorded data or audio. That means that there are 2 central questions that we have to think about. 1, how does it integrate the sound that is coming into the computer and synchronize it with the sound that's coming out? And how does it integrate by synchronizing all of these different connectable elements or components of the system? Because, again, everything needs to be synchronized. And, as we know, digital audio is not continuous. It is not temporally or continuous in the domain of time. It is discrete. So we have to think about, how does all this stuff link up? How does it lock together? All right. So the first concept here is latency, and latency is, when we're talking about digital audio, a short delay between when audio enters a system and when it exits. There will always be latency. There will never be digital audio that doesn't have some sort of lag. Why is that? Well, it takes time to process information in a computer. Now, computers have become very, very fast, but still, there will always be time to process that information. Just like there will always be time in between samples. Even though we might be sampling at a very, very fast rate, there will always be that time in between, and there will always be the time that it takes to convert all of those samples into something else, then convert them back into, basically what we're looking at here is all of the ways in which this delay is created and compounded. So here, you're recording your guitar, and you want to listen back to your take as you are playing. So you have headphones on, say, and you're trying to do this guitar track, and you're trying to synchronize with a drum track that is already recorded there. And so it's important for you because you want to hear what your guitar sounds like as you're playing, and you want to be able to synchronize with the pre-recorded drums. So your guitar has to be converted from an electrical from a waveform in the form of electricity that's in the cables. It has to be converted into digital information. This is what we talked about last week. It has to be turned into a series of samples. So here, it gets converted into digital information. It is now samples. It is now discrete. From there, those samples have to go into the DAW, into the Digital Audio Workstation. And those samples have to be then converted into usable information. So what happens is the computer takes those samples in chunks. The computer wants to see, the computer does not want to just look at one sample at a time. It's more efficient for it to really take chunks of samples and deal with them in that way. But of course, that takes time in order to process these samples into chunks or windows. So that's what when we're talking about buffering, that's essentially what's going on, is the computer is dealing with a certain chunk of audio data at a time and then moving to the next chunk. Because remember, this is like a constant stream of data coming from your guitar. And the computer has to deal with this constant stream as you're playing. So it is then converted, it's put into an audio driver. So when we see core audio, it's really just an audio driver, and that driver is making the data readable by your digital audio workstation. So the digital audio workstation isn't just like looking at one sample at a time. It's getting a packaged form of data so that it can more efficiently deal with all of those bits and bytes. This process then has to go in reverse so that it can be converted into something that you would hear in your headphones. Now, with DACs, with digital to analog converters that we have now, and with processing power of pretty much most computers, latency we can get it down to low enough that it doesn't really bother us as humans, as far as like there isn't such a delay that it's hard to that it's distracting when you're trying to synchronize your own performance with the computer. Because we're able to get it down to about 5 milliseconds is right about where it starts to bother you when you're trying to synchronize your performance with the computer. And so with most DACs and computers, we're able to get it down to 5 milliseconds or less now. But when we get the latency down, we are using a lot of CPU, and so it's always a balancing act. So you might find that if you have a whole bunch of effects in your DAW and you're also trying to record, you might crash the DAW, or the DAW might just say, I can't record because there are too many effects. And the reason is because there's so much processing happening at the same time. And all of that processing has to happen within this incredibly short amount of time, within 5 milliseconds, say. So if you're recording and this becomes a problem and you have a bunch of effects on, you might just turn the effects off while you're recording, and then you can turn them back on when you listen back. And that's fine. Point being is that latency, the lower the latency, the more of a CP load there is. The other concept I want to introduce you all today is word clock. And this is really about how all of this connectivity and synchronization happens when we're using a DAW. Word clock is a sample accurate master clock that holds all audio components in sync. So the word clock is typically going to be in the computer from which the DAW is. So whatever is the main digital audio workstation, that computer will be responsible for generating the word clock. And what the word clock is just a pulse that happens on every sample. It's not counting up. It's just saying now. It's just like 1, 1, 1, 1, now, 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 now. And it's happening on every sample. So if you're recording in 44,100 samples per second, it's sending out a pulse 44,100 times per second. And that pulse, all of these other hardware components are going to synchronize to. So why is this important? Well, because you want everything to be in sync, right? Like, you want, like, if I'm recording my voice into this computer, the digital to analog conversion that's happening needs to be in sync. Everything needs to be in sync. So this is how the word clock works. Let's compare that. This is how digital audio does synchronizing. How digital audio synchronizes multiple hardware units. So whenever you're connecting a computer to anything else, this is how the audio is synchronized. Let's compare this with another mode of synchronizing multiple hardware devices, which is the SMPTE timecode. So when we're dealing with video, we are going to be using SMPTE, which stands for the Society of Motion Pictures and Television Engineers. And this is a time code that synchronizes video cameras with other devices. So this was developed for film and video. I don't know if this image is familiar to anyone, but like old television, you might see this sort of image, or if you ever recorded with an old camcorder or something, you would see this time readout at the bottom of the frame. And what this is SMPTE timecode. And here, this is how to read it: hours, minutes, seconds, and the last number, frames. So we were talking about the relationship between video and audio sampling, in that motion pictures are all about frames going by at a fast enough rate that we perceptually connect the dots. Now, when we're talking about video, the frame rate is usually 24 frames per second. Sometimes it's up to 40. But typically, even with digital video, it's 24 frames per second. So SMPTE timecode is a way to keep track of the sequence of frames and number them. And it is a time code that divides each second into 24, or whatever the frame rate is. It's typically 24. So SMPTE timecode has a bunch of information that comes along with each frame. It's not just within the frame number, but the second, the minutes and the seconds where that frame is. So you have information that lets you know the sequence of frames that is attached to each frame. Now, how is this different than word clock? Well, SMPTE timecode is 24 frames per second, at least, at the slowest, and word clock is at the slowest 44,100 samples per second. So word clock is not just a little bit more precise, it is so much more precise in the way that it measures time discretely than SMPTE. And so this is why you get, I don't know if any of you have had this experience, but if you have recorded video with, say, a video camera, and you recorded audio at the same exact time with maybe an audio recorder, and then you try to synchronize those two later when you're trying to mix them together, and this is exactly what's happening in this screenshot here. Below we have the audio, and then we have video that was taken above. So say you're trying to synchronize the two. Some of you might have had this experience where over time, if it's a really long shot, over time you might notice, wait, it's not in sync anymore. Did I mess it up at the beginning? No, it was in sync at the beginning. The problem is that SMPTE is accurate to 24 times per second, whereas audio is at least 44,100 times per second. So over time, SMPTE starts to drift, just because it's just not even close to as accurate. And so that's why a lot of times we get drift between audio and video. So there are ways in which we can get the video to synchronize with the word clock while we're recording video. There are also ways to fix this later. As far as we're concerned, we're never going to be dealing with video in here, but I assume, it is the 21st century, that all of us will eventually be dealing with audio and video at the same time. And so knowing about this now will be useful for when you take on a project like this in the future. It's also a way to really understand the importance of word clock, why it's such an important, why this clock in the middle of the computer is so important. It is making sure that all of these devices are on the same page. And in this, in the case where you have drift with the video and the audio are just not on the same page, because the video is flipping pages 24 times per second and the audio is flipping pages 44,100 times per second. So word clock is all about getting things synchronized. All right, this takes us all the way back to the Digital Audio Workstation. And here we see a Studio One window. If I have this open, then that means that my computer, that my computer is generating word clock that is being sent out to whatever audio devices I'm using. All right, let's just get out of here and let's actually open up Studio One and take a look at what's going on inside. Okay, so in order to get Studio One working on your machine, I will take you through that process. So if I Google Studio One, and then I go to this PreSonus website, here we are. This is PreSonus, the company that designs Studio One. We're going to go to their products page. Oh, I see. Well, so if I click on the products, then I get this drop down, and then I'm going to just go to Studio One. Okay, so Studio One, here we are. I'm going to go down. Right. Okay, so if I start to scroll down, eventually I will find Studio One 5. This is the brand new version of Studio One. Oh, wow, look at all the stuff you can do. Really what we want is the download. So in order to find the downloads, I had to sort of scroll until I got here from the main site. And then if I go to downloads, Studio One. Okay. And what I'm looking for is Studio One Prime. Let's see. reference manual, blah, blah, blah. This is all documentation. Why won't it? Let's see. Looking for Studio One Prime. Maybe if I go, no. See, but this is why I do this, is because sometimes when I say just go there, digging through this website can be a little confusing. Right. Right. Click on buy. Now, I told you it was free, right? But buy now. I told you that it was free, and it is. But they stash the free version in the buy page. So, and the way that I got there, just as a reminder, this is why I do this, is like the website is kind of, so if I click buy up here, basically, it gives you these options. But if I click buy down here under Studio One 5, then it takes me to this page. So the reason is PreSonus is selling a whole bunch of stuff. One of the things they're selling is Studio One. So you want to go to scroll down to Studio One 5 and click buy now. Don't worry, you will not have to buy anything, because you will scroll down until you find Studio One Prime. So, which is free, right? So all you have to do is add it to your cart, and you will then log into checkout. As soon as you log into checkout, you will be able to download Studio One onto your computer and open it up. I'm just going to open up rather than go through the whole process of downloading, just to save on time. Okay, so when I open up Studio One, let's see. When I opened up Studio One, let's say you're opening up Studio One for the first time, you'll notice that it takes a while to load. So right now, it's loading all of this stuff. So again, taking us back to thinking about the computer, all of this stuff is stuff that I wrote onto my hard drive when I downloaded and installed Studio One. And then it all had to load into RAM so that my CPU can now do all of the processes that Studio One asks it to do. So that time, with the ... this is loading, ... this is loading. That's a whole bunch of information, a whole bunch of protocols that are being loaded onto RAM. Okay, so here I am in Studio One. Let's see. I'm going to start. I'm going to click Song. What Song is going to do is it's going to have this pop-up window will open up. And this is the window that is where I'm going to set up all of the parameters of my Studio One session. So from here on out, I will be referring to a session as a Studio One file within which we're going to do all of our composing, mixing, etc., etc. Here, when I'm opening this up, I can name this session. I'm going to say session. I don't really like song because it implies a particular type of music. I mean, what if we were recording a symphony orchestra that was playing Beethoven? That's not really a song, but that's just me. So let's say the title is going to be Welcome to Studio One. Okay, that's my song title. Now here, underneath the title, this is going to allow me to select where I'm going to save this session 2. So this session is going to be saved onto my hard drive somewhere. Here it's under songs, which is under Studio One and is in my documents folder. And I could decide to save it somewhere else. Now, this may seem very straightforward, but this is super important when we're talking about DAWs, when we're talking about digital audio workstations. Why is that? Well, okay, so why is that? Once I create this session, you'll see. I think I'll be able to explain why that's super important. Like knowing where the session is saved to is very important, because eventually you're going to have audio that is a separate file. So knowing where this file is, where this Studio One file is, and knowing where your audio files are is incredibly important. Okay, so I can set up this session, this Studio One session, so that I have different sample rates. For in here, let's just stick with 44.1. But I'm pointing out that, okay, here is where, here we're starting to understand why the sample rate issue was an important thing to talk about. Before I can even open a new Studio One session, it's asking me, what do you want the sample rate to be? What do you want the bit depth to be? Time base. This will make more sense when we open up the session. Don't worry, some of these you can change once you open up the session. So time base is just going to be how we're reading time. So thinking back to looking at waveforms and how time goes from left to right. Really, it's just what type of ruler do you want to be using? Seconds, samples, bars, which would be the musical way of looking at it, or frames. I'm going to stick with bars for now. You can change the song length later. This is just the default that they start you with. You can change the BPM later. This is just the default that they start you with. Once you set up the session, you cannot switch between sample rates. You cannot switch between bit rates. For in here, let's just stick with 44.1 and 24-bit. But just for future reference, once you start a session, you cannot switch these, right? Everything is sort of, so if suddenly you get some recordings that you want to add in that are in 96 kilohertz, then you want to start a new session. You want to create a new one. Okay, so when I click OK, this creates a blank Studio One session. So here I am in this blank Studio One session. Let's see. I'm trying to remember where I stashed those audio files. Let's say that you wanted to put your field recording into Studio One and do something with it. Great. Let's say you wanted to take your field recording and throw it in here and mix it. So this Dr. Freezy, this is the same audio file that I did the MP3 demo with, but this could be any audio file. This could be your field recording. This could be something you got off the internet. Could be something that you recorded at home. All I had to do was drag and drop. And this automatically created a new track for me. Okay? Another way to do this, I could also alternatively go to import file from song and then find wherever the wherever, look for the file wherever it is on my hard drive, and click it, and it would import it. So that's another way to bring a file into an audio file into my Studio One session. So yeah, let's see. Let me take you through that process just so you can see. So I go to my desktop. Okay, here is another jazz tune. If I click that and then click open, interesting. Where did it go? Well, I think that it must have put it, let's see, audio track, add track. Okay, so I'm going to add a new track. I want it to be an audio track, and it's going to be stereo. I'm going to click OK. Oh, this gave me 4 new tracks. Okay, so I might need to, be that I have to, right, that's right, that's what happened. Okay, so when I click import, if I'm importing a file, I need to be importing it to a track. So what happened before when I confused myself, I already had dragged Dr. Freezy in, and I had that track selected. And then what happened is when I put import, then it imported this second audio file into that same track, and they were on top of each other. So if you're going to import, if you're going to use this method of bringing audio into a Studio One session, make sure that you create a new track first by going track, add tracks. So here now I've got 2 waveforms that I have brought into my edit window. So where the window where we do editing, we're going to call the edit window. And already you see, okay, these are 2 waveforms. So I can kind of drag this to really get a better look at the waveform itself. Across the top, this is my time ruler, and I can move my playback head to different places in time. So let's see. Aha. So I wanted to play back, and here comes our first lesson in the intricacies of connectivity when we're talking about digital audio and computers. So I went to play, and what happened was it played out of the internal speakers on my laptop. However, what I want it to do is to come out of the same, out of my digital to analog converter, which is what my voice is. I'm speaking through a microphone right now, and I'm listening back to speakers. And right now, Studio One thinks that I want to be listening out of my computer speakers, which is probably how most of you are going to do this. However, if you're using a digital analog converter, then you would want Studio One to be using that as the output. And since I'm making a video at the same time, and I want you to hear what's coming out of this, what's coming out of Studio One, if I go to Preferences, it usually would start here. I can change preferences for Studio One. The main thing that we're going to be dealing with in here is the audio setup. So right now, Studio One is, if I were to press record, it would be listening to the internal microphone on my computer. And if I were to press play, it would be going out of the built-in output. However, I can switch this so that so that whatever is coming in, like if I wanted to record my voice, for instance, it would listen to my DAC, and if I wanted it to listen to, and if I want to hear what's coming out of Studio One, I'm going to switch my output device. Okay, so now while you guys are working at home, you might not have to run into this problem so much. Definitely when we're working in a computer lab on campus, this is this constant back and forth between figuring out, making sure that your computer and your digital audio workstation are in agreement as to what is the input and what is the output. So we want to know, like in the sound settings in my computer, this happens to be a Macintosh. In the sound preferences to the computer, well, this actually will because I'm using the video capture software, it's going to be different. But here, I want to make sure that the outputs conform with one another. With that both Studio One and my computer both are listening to the same place, and they're speaking out of the same place. Okay, so here we are. We have these two audio files. They're both in here. I can move my playhead to any given point on this waveform. If I kind of toggle this or move this slider down here, this allows me to zoom in and out really quickly, which is convenient. So I'm zooming in, and we're starting to see much more close up in the waveform. And as I zoom closer and closer, you can start to see when we've been talking about wiggles in the air. Here we are seeing these little wiggles as I'm zooming in on the waveform. So here I am now. You'll notice that, I'm clicking in between these hash marks on the ruler, and my playhead is going to the hash, whatever hash mark my mouse is closest to, it's correcting to there. Now that's because it's snapping to my ruler. Right up here you see snap adaptive. Let's say I wanted to zoom in right here, but it keeps moving my playhead to either side of right where this waveform starts. So what I'll want to do is I could either turn off snap to grid. That should do it. Right. So I've turned off the snap, and now I can move this playback head to any place, to really any sample. So now I can zoom in, and I can just move this playhead wherever I want to. So when we are editing, right, and now you'll see, I can really get very, very microscopic with this playhead as far as like where it starts and where I start listening back, right? So if I press play, that is the playhead is the time that I am in the track, in the waveform. I can also select certain parts of the waveform. I can start. So now if I select this section of the waveform, basically what I'm trying to demonstrate here is that when I'm reading this track in the edit view in a digital audio workstation or in Studio One, I'm thinking about, this is time going from left to right, and this is my wave form. As time goes from left to right, and I'm trying to select portions of, let's say I just wanted this drum hit. Let's say I wanted to get rid of this, whatever it was. I'm thinking about this as trying to translate between, okay, so this is this moment in the track. This is that one particular drum hit. I'm going to copy it, or whatever it is that I want to do to it. If I want to be getting really, really precise in what I'm selecting, I do not want to be snapping to a grid. However, if I want to be making something rhythmical, then I would want to be snapping to a grid. We'll talk about that next week. For now, what I want you to do is practice getting audio into a track. So try putting in maybe your field recording, or if you want to just throw in a song and just throw it in, get sound to come out of Studio One and get used to moving around, moving your playhead around. Try cutting, try pasting, try selecting. Now, here is an important thing for me to demonstrate here, as far as like cutting and pasting or whatever. Let's say I were to select this, and let's say I were just to cut it out, right? And this will be how we get all the way back to understanding why it's important where you save your files to. So I cut that one hit out of my first track. I'm going to paste it down here. I'm going to mute my top two tracks, and we will hear. Okay, so now I cut this out of this track. Now, did I cut that? If I were to then open up Dr. Free Z in a different program and listen back to it, this bit of audio would still be there. It would not be missing, right? The only place that this audio is missing is when I open up this Studio One session. Okay, so if I were to look at this Studio One session and find it on my hard drive, so wherever I put it in my hard drive, I believe it's in Documents. Studio One. Okay, so here I want to look at the file architecture of a Studio One session, and this will be the last thing I talk about today. All right, so when I saved this automatically went into my songs folder in my Studio One documents. Here it is. If I open up that folder, cache images, right? I am not seeing this audio, Dr. Free Z. Dr. Free Z is still on my desktop. It is not in with this Studio One file. That is why if I were to then listen to that off of my desktop, this portion of the waveform would not be cut out. It would still be totally the same. So what Studio One is doing is it's referring to this audio file that's on my desktop and sort of loading that information in, and all that I'm doing to this audio within Studio One is in reference to a file outside of my welcome file, right? So here is, so in this folder is where this is my Studio One file. If I were to then let's say I were to take this folder, put it on a thumb drive, open it up on a different computer. If I were to then open up this welcome file, it would immediately say, cannot find audio files, right? It would be searching for Dr. Free Z and SOL Blues and would be unable to find them because those are both on the desktop of this computer and not on the computer that I'm working on. So I wouldn't be able to work on my stuff. So what I would want to do is I would want to copy a version of these audio files that I have within Studio One, and I would want to put them in a file within this Studio One session folder, so that if I were to open it up on another machine, it would find the audio files immediately. Studio One does not have, a Studio One file is not an audio file. A Studio One file is a Studio One file. It is a file that tells how to set up the session, where to put the effects, all of that. And it has instructions on where to find the audio that you are playing with. So this is another important thing to remember, especially when you're moving from machine to machine, or sometimes your own machine will lose track of where the audio is. The thing is to just find that original audio file and direct Studio One to it. Okay, so put some audio in here, try messing around with copying and pasting, and just see what happens, and know that when you copy and paste, you are not affecting the original, the actual audio file. You're just telling Studio One what you want it to do with the audio file, if that makes sense. One last thing I'll point out, I know I'm going a little bit over time, my apologies, but I did want to point out one last thing that I want you to try playing with. If you go into View and you go and you open up Console, that will bring up your mixing board. So this is one other thing you could try messing with. So for instance, if I were to unmute these two tracks and we were to listen back, so you get the point. There is a relationship between the track, or between the waveform and the channel, the track that we see in the editor and the channel that we see in the console. So that's one other thing that I want you to sort of familiarize yourself with. So put an audio file into a track, open up and try copying and pasting and some other, kind of just play around in there, and then also start familiarizing yourself with fading the volume in and out, and maybe throw in another audio file and start messing around with two tracks at the same time. We'll talk about all of this stuff on the next time we meet. Until then, have a fantastic day. We will see you next time.